I've been asked to say a bit about global trends in waterway and catchment management, but I want to take a step back and start by talking about some global trends in broader environmental management, not just water, but water and land. And I want to pick on three that you can see up the top there. The first is the way we perceive change in nature. And the second is the growing emphasis on understanding root cause and addressing the ultimate cause rather than symptoms of environmental problems. And the third is what we've learnt recently about the factors that are conducive to communities participating in environmental management. And after going through those, I then want to look at three examples of estuaries around the world, waterways and estuaries, where you can see some of these elements are being applied and some aren't. So let me start with the first one. And the fact that you see Herodotus up there on the top right is a hint that the way that we perceive change in nature has been a long time coming. So for the last 2,500 years, the dominant view of nature is that it is in equilibrium. In other words, that if it is perturbed by human or natural forces, it tends to return to its former state. And so up there in that column are the attributes of steady state management, which have really dominated environmental management for most of its short history. So the reference point is a historic baseline to which we try and return. The goal is to maintain that original state or return to it. The approach is to restore composition and structure. And if we look at nature, we can value it broadly in three different terms: the composition, or what's there; structure, or how it's arranged; and the function, what it does. And what we've tended to do is focus on the things that are easy to measure, which is composition, what's there, and structure, and try and return to that. And what I want to suggest is that has left us short, and it's why a lot of environmental management has struggled. The attitude to disturbance has been to minimise it. The role of research is to inform managers, and the role of managers is to make decisions. Okay, so in about the 1940s and 50s in the United States, ecologists began to question this idea of equilibrium and balance. And one of the triggers for that was the Dust Bowl. So particularly in the states of Oklahoma and Texas, a combination of economic depression, drought, and poor farming practices meant that certain ecosystems and whole landscapes shifted to a state from which they were never going to return. And that was very obvious. And that brought about a shift in thinking. And I'll throw up in a minute a couple of what were the seminal publications that really triggered this. And one was by an ecologist called Richard Lewontin, who first put forward evidence that nature can exist in multiple states. There isn't just one that we should aim at. And that was in 1969. 1972, a man called C.S. Holling gave us the term resilience. And he talked about thresholds of change, and he used a political metaphor. That ecosystems remain in a certain state, and when a threshold is passed, he talked about regime change. They go to a different state. And we have a preference for a particular state, a nostalgia for a particular state, but what they're arguing is nature can exist in many states. And so that's about the 1960s and 70s we're up to. In the 1980s, we see the first evidence in government documents. So the National Research Council in the United States came out with a book called Ecosystem Management, and that was the beginning of this new trend. The US Forest Service was one of the first to adopt what they call ecosystem management, and its characteristics I've put up there. So the reference point is not a particular baseline state, but the trajectory of change that an ecosystem had been on. The goal is not so much to maintain the original composition and structure, but to maintain functional integrity. Now I'll come back to that challenging term in a minute. The approach then was not to try and restore the original composition and structure, but to ensure that that ecosystem had adaptive capacity, that when the next shock came along, it had the ability to respond and recover. The attitude to disturbance was to use them as windows of opportunity and not necessarily resist them. The attitude to research was, the role of research was to collaborate with managers. So the research was being done in a real world context, not isolated. with limited boundaries as small experiments, but they were done in the real world at the scale at which the problem exists. And the role of the manager was not to make decisions, but to facilitate communities to become involved. Now, this is fine in theory, and what I'd suggest to you is it exists largely in principle and theory, and it doesn't really yet exist in practice. And what we do now is we straddle those two worlds between steady state and ecosystem management. The intention is the right-hand column, the reality is often the middle column. And I'd suggest there are 4 reasons why that's the case. One of them is that challenging term functional integrity is very elusive. Last time I looked, there were 22 different candidate indices of functional integrity. They're all complex, they're challenging. I don't think there's any danger they're going to be applied anytime soon because they're very difficult to apply. Even though that is the intention, it still remains an elusive goal. And so because we can't really get a handle on how we measure the metrics and indices of ecosystem function that would be generalisable across ecosystems around the world, we tend to fall back on composition and structure as our measure. There's a push within ecology to recognise what are called novel ecosystems, so hybrid ecosystems, a mixture of endemic and exotic species. And if you really consider it, a lot of the world consists of novel ecosystems. And one of the person spearheading this movement within ecology is an Australian ecologist called Richard Hobbs. In 2013, he put out a book called Novel Ecosystems. Accepting the Ecological New World Order was the subtitle. So again, a political metaphor and very challenging. 2 years before that, he published a paper with various others in the journal Nature that was simply called Don't Judge Species on Their Origin. The implication being, judge them on what they do, not where they come from. 2 weeks later, there was a rebuttal published in the pages of that same journal Nature, simply headed, Introduced Species, 141 scientists disagree. So within ecology, there is no acceptance of novel ecosystems. So ecologists straddle those 2 columns as well. And at the moment, we focus very much on composition, even within our environmental legislation and law. If you think of it, our primary piece of environmental legislation, the EBPC Act, Environmental Protection and Biodiversity Conservation Act, its main function is a schedule at the end which lists 1,400 threatened and endangered species, and they become the focus. Now, I'm not saying that's not a good thing to do, but we should also be looking at function, not just how rare they are and where they come from, but their role in ecosystems. And that is a long time coming. Another reason why it is challenging to move from that middle column to the right-hand column is that our cultural history and our nostalgia for the past are baked into environmental policy. Try again? Yep. They're baked into baselines. Now, this is a quote from an environmental writer called Emma Maris. And what she says is the history of European exploration and colonisation is a white guy turns up in a boat and things go bad. People and nature suffer and the date goes down in history. And it just doesn't go down in history, it goes down in environmental policy. So if you look at North American environmental policy, you'll see the phrase pre-Columbian peppered through. So the objective is to return ecosystems, or to use as a standard the pre-Columbian state, meaning before Columbus. The guy next to Columbus, his name was Hernando de Soto. He was a conquistador. He left Mexico, headed north, looking for the fabled city of El Dorado, made of gold. He didn't find it, but he and his conquistadors left 2 legacies. One was they reintroduced the horse into the Great Plains of North America and created a whole new genre in art and literature and film. But he also left behind that date. And in Arkansas and Mississippi, it's written into forest legislation that the baseline state that they strive to achieve, at least for representative parts of the forest, is the 1540 state. You'll recognise the guy next to them. Why we have 1750 written into our environmental policy, I don't know. James Cook turned up in 1788. But for the last 25 years in forest policy is a statement that says that 15% of all pre-1750 forest types shall be preserved as representative of that former state. And the last one is a fellow called Ebenezer Zane, who turned up on the Ohio River and said, look, this is a great place for a town. And ever since Ebenezer Zane turned up, the reference point in that part of Ohio is the 1807 condition of the vegetation. So that's the second reason. The third reason is simply time. Okay, so there is a wonderful network of long-term ecological research sites in the United States, 28 sites that represent all the major biomes, and they were reviewed in May this year in a series of publications. And it's a very sobering realisation to see how long it took at each of those sites to detect significant change in certain characteristics. Now, these were not management sites. There were no major interventions. They were just, people just sat there for 80 years in one case, 40 years in others, and just monitored ecosystem processes. And you can see how long it took before they detected any genuine change. If you look at the one where it says 60 years, trend in sea surface temperature, California coast, that's been monitored for 60 years. From the first 20 years, if you look at the data, there is no signal. It's just variability and noise. If you look at the next 20 years, the same. If you look at the third 20 years, there is no significant change. But if you put all three together and you look over 60 years, you can detect a significant increase in sea surface temperature. Now, most of these are detecting change in climate and change in human land use in the surrounding catchment of those sites. There's no major intervention, they are just watching. They're incredibly valuable as a resource to understand ecosystem process. And you may not know that there is a global network of long-term ecological research sites, of which Tasmania hosts one in the Southern Forest in Warra. Not only does it host it, but an event occurred 2 years ago, which is the sort of thing they're waiting for. Not that they want it to happen, but part of the reason for passively sitting there and monitoring is to see these pulse events that tip an ecosystem from one state into another and understand what was the threshold, what tipped it. So a fire went through the site. If you may be able to just see in the bottom right-hand photograph, you can see a forest canopy, there's some forest scorch or crown scorch, and you might also see a tower. So there's a tower that sticks above what are the largest flowering plants in the world, and for the last 10 years has been monitoring the flux of carbon dioxide and water vapour between the trees and the atmosphere. Every minute they get, it's like taking the pulse of that forest. They follow its growth and detect any change. And one thing they've realised that in summer it's at the upper limit of its capacity, its physiology, to keep pumping water to the top of those canopies. And many days in summer it just closes down and waits. And that would be a suggestion to say we may be on the verge of a regime change. In other words, the composition of that forest may change to species that are more drought tolerant, probably not the same productivity. And so this event is an opportunity. A lot of the equipment was burnt, tens of thousands of dollars of monitoring equipment and cables went up in the fire. They've all been replaced, and now they're waiting to see what happens. Will the understory be replaced as it was, or will there be one of these regime shifts into a slightly more drought-tolerant ecosystem? Okay, so I'm labouring this point because accepting change and understanding the dynamism of ecosystems is one of the really big global themes or trends in environmental management. I think there's a fourth reason. Have I given three? So our inability to understand functional integrity, the idea that we've got these historic baselines, and then there's simply the time it takes to detect change, the extreme difference between environmental time and human lifetimes. The fourth, I think, is a very understandable human desire for stability and order in the universe and predictability. And a lot of that is wishful thinking. It is not there. And what we need to accept is dynamism. That doesn't mean that we stop trying to protect rare and endangered species, or we forget about endemism, but we think of them in the context of function, as well as the composition and structure. Okay. The next one is a quote from a man called Richard Levins. that the boundaries of consideration should be isomorphic with the boundaries of causation. Isomorphic just means same shape as. Anybody who's worked in catchment management, this statement will come as no surprise. If you're managing an estuary or a river, you need to extend your boundary of consideration to the watershed, the whole watershed. Because the drivers of river and estuarine health extend right to the limit of where that water comes from. But there's another aspect to what Richard Levins is saying. It's not only in problem diagnosis that we need to think of causal pathways and identify root cause, it's also in designing interventions. And what he's really arguing is if you design an intervention, you also must be able to construct a very detailed causal pathway to explain why you think what you're going to do is going to work. Now, scientists call that a hypothesis, and there is another word emerging in environmental management around the world for hypothesis, and that is theory of change. Now, a number of organisations that fund major social and environmental change, the UN Development Programme, Oxfam, Amnesty International, Conservation International, Greenpeace, before they fund major programs in social and environmental change, they insist on a theory of change. Theory of change is just a friendly word for a hypothesis. You state why you think your intervention will work, you detail every step in the way, and you say how will you measure it. And the measurement, the testability, the last of those three elements is vital, because if you can't tell why your intervention worked or didn't work, there's no opportunity to learn. And the history of environmental management has been, let's try this. Oh, didn't work. And you don't know why, because you didn't have indicators that were sensitive enough to pick up what it was you did and didn't do. So that saying of Richard Levins, to me, it just, I think, is one of the most useful mantras in environmental studies. That the boundaries of consideration must be isomorphic with the boundaries of causation. If they're not, you have very little chance of succeeding. And now I'll come to the third one. Okay, so this is Elinor Ostrom. She's the first woman to win a Nobel Prize in economics, which was a major achievement because she's not an economist. She's a political scientist. Her interest is in what makes communities, or what conditions make it conducive for communities to get involved in managing natural resources. And what triggered her life's work and those of her students that for which she was awarded the Nobel Prize was a paper published in the journal Science in 1968. And that paper was written by a man called Garrett Hardin. He was then president of the Pacific chapter of the American Association for the Advancement of Science. And each year the president delivers a presidential address. And that year, his 1967 presidential address was published in the journal Science in 1968 as an opinion piece. It's ironic it's in Science because it is completely uncontaminated by science. It is an opinion piece, and it basically argues that any natural resource managed in common by a group of people will be degraded because no one person is responsible. It's essentially an argument for private property. And the only support he gave was that of an obscure English economist called William Floyd, who again was expressing an opinion. No data at all. And Elinor Ostrom thought, I wonder if this is really true. And so she set about with her students, and over her career they compiled about 100 studies of communities, contemporary and ancient communities from history, who had managed a resource in common, a fishery, a forest, an irrigation system. And at the end result of that, in 2009, the year she was awarded the Nobel Prize, in the same journal as Garrett Hardin's paper, she published a paper with a title so complex I'm not going to read it out. But the end point of it was, of all of the case studies they looked at, the ones that were successful had several factors in common. Now there's a lot of them, but they come in groups. There were geographic, social and institutional features that they all had in common. The geographic ones were the size of the resource. If it's too big, if it's the size of the Murray-Darling Basin, you're not going to get a community to communicate and participate across that huge area. Similarly, if the production is extremely low, if it's semi-desert. Also, if the production is highly variable. So the Murray-Darling Basin would fail on two counts. One, the huge variability in flow, and its size. So you'd have to break that down into subcatchments in order to apply Ostrom's principles. But what is most interesting is it's the social and institutional factors that determine whether or not communities can successfully manage what's called a common pool resource. And key among those are the fact that there need to be rules and sanctions that are agreed by the group. There's a process for dispute resolution. And one of the most important is the very bottom one, that wherever that group exists, they must be recognised by the next level in terms of governance to have the authority to manage it. If their authority is not recognised, they have Buckley's chance of getting away with it. And I think what's interesting is you can see some of those applied. I'm going to quickly skip through my 3 examples. I really think these big trends are the important part. I just want to now talk about a couple of different estuaries and what happened. Now, I have no personal knowledge of these. This is done from a distance. I'm really just looking at headlines, but there's a story, I think, in each 3. The first one is the Peel-Harvey estuary. So it's 1 million hectares in size. If you know Western Australia, it extends right out to Wickerpan in the wheat belt. There's 1 million people living around the estuary, mainly in the city of Mandurah. First evidence there were trouble algal blooms in the 1970s. Lots of reports, lots of opinions. Most of the opinion and the consensus was a multifaceted approach. We need to address fertiliser use in the catchment. We need to streamline the waterways and the irrigation channels. A whole raft of remediation. In its wisdom, the government decided it would go for an engineering solution. And this is, I think, a good example of that saying, for every complex problem, there's a simple solution that's wrong. They spent $76 million on that cut you see through the ocean. So that's not natural. That's the Dawesville Channel. And then they thought, well, now we can keep building canal developments. Now, the fact that the Peel-Harvey Catchment Council, a not-for-profit, started 6 years later tells you something. It hasn't worked. And so now we're back with that raft of different approaches. And only last year, the West Australian Government launched its Healthy Estuaries program, which contains that raft of different strategies that were first proposed in the 70s. There are 6 catchments in WA that are at an alarming state. They all share the fact that it's fairly flat, highly transmissive soils, high levels of phosphate fertiliser. They're all in trouble. There is now a government program, but as you can see, we've got a double-headed strategy. We've got a not-for-profit community group, which is not particularly well resourced, and a government estuary program. Now, I don't know how well they work together, but what's interesting is that we've got this double-headed approach. If we look at this example, which is one of the poster children of estuaries and environmental management, Chesapeake, the catchment of Chesapeake Bay is the same size as Peel-Harvey, 1 million hectares, but it has 17 million people living around it. And if we just go to the bottom line, over those 38 years, the population has gone up 30%. But 2 of the key factors in estuary health, the load of phosphorus and nitrogen, have both declined. So something is happening. And what appears to have happened in the 80s, the 6 states and the federal government combined and formed a legal partnership and agreed on targets and indicators, and that would appear to have been part of the reason for its success. My last one, the Danube River. Now, this is the most international of all rivers. 80 million hectares in the river basin, 19 countries, 80 million people living around it. Somehow, they held a convention in 1988 and all 19 countries signed on. And they agreed on monitoring methods and indicators. They also agreed on 3 criteria for monitoring sites: international boundaries, tributaries, and point source pollution. They've been doing that, and in a surprisingly short period, if you believe their headlines, and from what I've read, it appears to be legitimate, they've had a positive impact on particularly nitrogen and phosphorus in the estuary. So it comes back to this point about governance that I think we got from Elinor Ostrom. If you can create the conditions conducive to people collaborating, you've got far better chance of success. And I just want to finish closer to home. About 5 years ago, I was involved in organising a workshop that brought people managing major environmental programs from around the world to Hobart. So we had people trying to change fire regimes in the Kimberley to protect grassland species. We had people trying to construct a 1,200 kilometre wildlife corridor in the southwest of WA. We had a group restoring environmental flows to the Klamath River in Oregon. We had people eliminating introduced pests from offshore islands in New Zealand. We sat down for 3 or 4 days, we heard each of the case studies, and then at the end, we came to a conclusion about what were the factors that determined the success of those that had been successful. And the first one was you had to achieve those, you had to meet those 4 conditions. That any plan had to be biologically feasible, socially acceptable, financially viable, and institutionally tractable. By tractable, I mean you had to get the partnership or agreement of all levels of government and regulatory authority involved. They all had to be involved. But perhaps the most surprising thing, given they're all ecologists, most of them were, the conclusion we came to is this sort of ecological management and restoration is essentially a governance exercise. And it goes back to Ostrom. If you get those characteristics right, you're far more likely to achieve success. And I will finish there. Thank you very much.